Okay, so write an expression in factored form for the polynomial of least possible degree graphed below. Okay, look, they're giving us fancy polynomials. They want us to basically take this and write an equation. That's kind of wild, isn't it? So you're getting pretty strong now in your ability to deal with graphs. I don't know if you've noticed the complexity has been growing. And by the time we're done with this section and the next one, you will have under your belt a lot of strong ability to deal with graphs and equations and how they connect. So look at that weird looking graph. Can we look at a weird looking graph like that and come up with an equation? Yeah, it's actually not too hard if you know a couple of things. Let me show you. First off, you have to know about the zeros. That's the main thing. This is a zero, this is a zero, and that is a zero. So the zeros, or they're also called roots, right? Either name. Okay, this one is different than these guys. Why? This guy, so basically here's the deal. If you have, let me just give you some examples. I'll have to put this in the notes for you too. So basically if you have one that just, well, let me not start with that one. If you have one that just passes through like that, yeah, I don't like the way I'm doing that. Yeah, okay. Yeah, I like that better. Okay, so that root, call this R1, that would end up being parenthesis x minus R1 first power in the equation. Whereas if you have it, let me try to do a better job on that. You have it more like this, where it comes down and barely nicks it like that. That is x, and this is R2, root 2, squared. You know, I hope I'm not confused with the 1 and the 2. Let me get rid of the 1 and the 2. Call it R, because that's really not the deal. I don't want you to think it is. There we go. Yeah, so if you, there it is. So if you have a root where the graph just passes through, then it's first power. So graph passes through first power. See the first power there? Whereas if the graph hits 0 with a U shape, and hits 0 and bounces, let's put it that way, bounces instead of passing through. It bounces, that's second power. Whenever it bounces, that's a second power. Okay, so, and it's always x minus the root. So in general then, coming on down here, we know our equation is k, and there's always a k in the front, x minus, and what is this? -2 second power. This is going to be second power because it bounces here, right? This one bounces. In fact, let me just put a B. It's bouncing right here, whereas here it passes through and passes through. So this is going to be first power and first power for both those. So then we're going to have x minus y equals x minus 2 first power, x minus 4 first power. How are we doing so far? Is that making sense? So as you look at a graph, you find the zeros, also called roots, and you find out, does it bounce or does it pass through? Pass through. Wherever it bounces, boing, wherever it bounces off the graph, like bouncing something off a trampoline or skipping a stone off the water, when it bounces, it's second power. When it passes through, those guys are first power. The bounce one is second power. And it's always x minus the root. And so what ends up happening then? We end up with k, x plus 2 squared, x minus 2, x minus 4. You don't have to show the first powers. You can show them if you want to. And now, okay, and now find k. How do we find k? Remember? Plug in the y-intercept. You always find k by plugging in the y. So what's the y-intercept? Right here. Over 0 up to. That's the y-intercept, because that's where the graph hits the y-axis, isn't it? There's the y-axis. This is the x-axis down here. See, right there, 0 to x is 0, y is 2, is the y-intercept. So plug that in. X is 0, y is 2. So y is 2. And x is 0, y is 2. X is 0, y is 2. See how I'm plugging in the y-intercept there? X is 0, y is 2. And then you can solve for k. So let's do it. 2 equals k times, what's that going to be? 4 times negative 2 times negative 4, right? This is 2 squared, 4. And so 2 equals k times, what is that? 2 negatives, it's going to be positive. I think it's 32. You should calculate if you need to. Last step, divide by 32, boom, boom. K is 1/16. So we got it. It's y equals k, remember, x plus 2 squared, x minus 2, x minus 4. Now we know what the k is. It's 1/16. X plus 2 squared, x minus 2, x minus 4. There we go. We were able to look at that graph, and from that graph, figure out the formula that'll work for that one. Now, I want to point out, that's the lowest it can be. Write an expression in factored form for the polynomial of least possible. So it's, again, the thing we were talking about before. It really could be a higher power. It's this at the least. And this is usually what it is. Usually they do form their least option. But I just want to let you know, it's not set in stone. It could be, it could have even a higher power. Like this, it's these powers that this is 2 at least, 1 at least, 1 at least. And there could be even more, but usually this is it. And there it is. It's all about, you just find the zeros. And anytime it bounces, that's the second power. Anytime it passes through, those are first power. And it's always x minus the root, x minus the root. Remember how we learned that? X minus the root, x minus the root at a 0. Now, why is it minus? Why is it minus? Well, because if you plugged in that root, like look right here. If I plugged in negative 2, for example, do you see how it's going to make it 0? You see that? Let me show you right here. If I plugged in x is negative 2, it's going to make that term 0, which is right, because at negative 2, the graph has a height of 0. Or if I plug in positive 2 right there, it's going to make that part 0. And they're all times together. So if just one of them becomes 0, the whole thing is 0. And same thing at 4, right? At x is positive 4, if I plug in x is positive 4, it's going to make that back one 0, which they're all multiplied together. The whole thing is 0, which makes sense because the graph is at a height of 0. At x is positive 4, positive 2, and negative 2. Do you see why that works? X minus the roots? It's got to be, doesn't it? And then you just find the constant in front by plugging in the y-intercept. And we've got the equation that quick and easy of a very complex graph.